Hello everyone. Today I'll make you understand what is CPG, edge computing, and why they need to combine with each other and with BIOS to improve the speed and gain of a soft quantum-path robot. So let's get started with CPG. What is CPG? First, CPG stands for Central Pattern Generator. That is a neural network capable of generating rhythmic oscillatory signals, and without requiring the constant input. In biology, CPG are responsible for controlling rhythmic motor behaviors, such as walking, running, crawling, or flying in animals. So this is still a bit hard to understand, so let me give you an example in our body, because our body is a great CPG system. So in our body, CPG is a neural network. Of course, it comes from the spinal cord. Spinal cord is this part in our body that generates rhythmic movement patterns, such as walking or running. And the important thing is that it doesn't require the brain to control every details. For example, when you walk forward, your brain just send a high-level command that move forward, and the spinal cord coordinates the motion autonomously. Like your left leg steps, right leg steps, and repeats. This is like a loop. So this mechanism reduces cognitive load on the brain. It enables fast reflexes, such as when you step on a hot or sharp object, your foot automatically and immediately lift. So that is CPG and how it works. So let's move to edge computing. As you know, we're living in a world with full of smart devices, such as phones, cars, sensors, or cameras, all generating huge amounts of data. Traditionally, all of this data is sent to the cloud for response, but this method is becoming too slow and inefficient in many situations. So that's where edge computing comes in. So let's take a look closer at what it is and why it is so important. So what exactly is edge computing? Edge computing means processing data closer to where it is generated, instead of sending it far away to a centralized cloud server. So let me give you a simple example. Imagine self-driving car. It collects data from sensors in real time and has to make decisions very quickly. So if it had to wait for the cloud to respond, then it will be too slow. Instead, with edge computing, the car can process data instantly right there at the edge of the network. So that is how edge computing works, bringing computation closer to where the source of the data is generated. So what are the benefits of edge computing? For me, there are three main reasons why it is so important. First, it reduces latency, which means less delay. It is so important in applications like autonomous car, online gaming, or smart manufacturing, where every millisecond counts. Second, it helps save bandwidth. Bandwidth is the speed of the data, like 100 gigabytes per second or something like that, because it processes data locally, so only necessary information is sent to the cloud. So it will make the network more efficient and cost effective. And the last one is that is improved privacy and security. Now sensitive data doesn't have to travel across the internet, which will lower the risk being hacked or leaked. So that is edge computing. And why do we need to combine these three technologies? It includes bio, CPG, and edge computing to improve the speed and the gate of software-to-pad robot. First, the robot uses a CPG based on Hop oscillator to generate a rhythmic leg movements. A Hop oscillator is a type of mathematical model used to generate smooth and rhythmic signals, just like those found in the biological system, such as the nervous system that controls walking in animals. So be back for the CPGs. It mimics biological system, allowing the robot to produce different style gates. And allowing the robot to produce different style gates and so let's move to why do we need to use bio. So to be but for the gate to be effective, we need to change the parameters of CPGs, such as amplitude, frequency, or phase offset between necks. So that brings us to bio. Instead of manually search for the optimal values to maximize the speed of robot, we use bio to try a set of parameters, observe the result, and use that to guide the next trial. And but the model seems like a great model now, but there's a big problem that what works in simulation often doesn't work on the real world due to the reality gap. Reality gap is the difference between the simulation and the real world performance. So to solve this, the researchers applied multi-fidelity Bayesian optimization. This method uses a combination of simulation data and real world test results to learn faster and adapt more accurately. So the simulation is used for large-scale exploration, while real data is used to correct errors and fine-tune the final solution. So now, why do we need to use edge computing? As you know, the computation is now very challenging, especially the learning part. It is so heavy, and the robot's onboard controller is too weak to handle it in real time. So they use edge computing. The robot sends the sensor data like speed and body orientation to a nearby edge server via 5G. And the server runs the CPG updates and Bayesian optimization and sends back to the updated control parameters the robot. It uploads the heavy computation, reduces latency, and allowing the robot to learn and adapt while moving. So in a summary, CPGs generate rhythmic leg movement while find better parameters over time to improve walking. Edge computing handles the heavy computation so the robot can learn and adapt in real time. So together, this combination achieves a more adaptive, faster, and efficient gate for the soft quantum robot. And the actual results in the paper upgrade the speed to 52.7% smooth gate transition and stable location on flat terrain. And this is our keywords in the papers and the link in the send direct. And thank you for listening. I'll be happy to any questions.
Thank you.